Howdy folks. Got one more example here for you where we're going to identify all of the qualities of the graph of a polynomial or all the important information of a polynomial that will help us graph the polynomial. We're not going to graph it until Thursday. We're just identifying all the important information today. So let's go ahead and knock out the easy stuff. What is the lead coefficient of this polynomial? Should be pretty easy. It's right there at the front, right? Lead coefficient here is -3. All right, what is the degree of this polynomial? What is the degree, right? It's the highest power, right? So the degree of this polynomial is 4. And lastly, last of the easy ones, what is the y-intercept of this polynomial? So on the very end there, okay, we got a positive 240. So the y-intercept is going to be 0 and 240. Okay. Now, in order to identify the roots or the x-intercepts of this polynomial, and in order to identify the factor multiplicity, we're going to need to factor this polynomial down. We need to reduce it down into its factored form. And in order to do that, we need the rational root theorem, and then we need to do a whole bunch of synthetic division until we have all of our factors. Okay? So the rational root theorem gives us p's. Let's see, what are the p's in this case? Of 240. Wow, that's a lot. Now my q's are factors of 3, which are just 1 and 3. Let me tell you what I'm going to do here. I'm not going to write them all down. Okay? What I'm going to do is, if I got this kind of written on the side, I'm going to be honest with you. I'm just going to try the numbers up to 10. If I got to go past 10, that's fine. And because the only thing is a 1 and a 3, and I know there's a 3 up here, that means there's probably only one factor that has an over 3 in it. So I'm only going to test the whole numbers. I'm just trying to be strategic here. Actually, I'll probably test the whole numbers maybe up to 20. All right, that's what I'm going to do. I'm just going to test the whole numbers up to 20, and then if I need to come back after that, if I need to get more after that, then I will. But I've done this enough times, and I know that most of the time I'll get at least one between 1 and 20. All right, so I'm going to test 1, -1, 2, -2, 3, -3, 4, is that right? -4, 5, -5, 6, -6, 8, -8, 10, -10, 12, -12, 15, -15, and then 16, -16, and 20, and -20. We'll test those, and then we'll come back to all the rest of them if we need to. All right? Okay, so let's start with 1. We'll put 1 in the half box. Not going to be equal to 0. Let's move on to -1. Erase these. Erase this. Put a new line there. Okay. Well, that's not going to be 0 either. So I know it's not -1. So I know we can eliminate 1. We can eliminate -1. Now we're going to try +2. +2. Not 0. We're going to move on to -2. And 240 is -20, still not 0. So it's not going to be -2. All right, let's knock that one off. Let's try 3. +3. And -80 times 3 is -240. Nice. Remainder of 0. We found our first one. First factor is x minus 3. The 0 is +3, but that gives us a factor of x minus 3. So we've got x minus 3. Okay? Now, remember that we have to test that number again because it's possible that there's another one in the function, right? But we're going to use these numbers now. We're breaking the polynomial down. So now we got a -3, a -29, a -88, and a -80. Not 0, so the second time we run 3 through, we do not get a 0 as the remainder. Therefore, there is not another x minus 3 factor, and we can move on to the next number. So we'll leave this here. We're going to try out negative 3. So try negative 3. Not a remainder of 0. Therefore, we know that negative 3 is not a factor, or is not a 0. It's not one of the roots. So now we're going to try 4. This is like 1,000, so I know it's not 0. So moving on, get rid of that. Oh, make that a negative 4. So we know 4 is not one of the roots. Now I'll try negative 4. And sure enough, we get a remainder of 0. So that means that negative 4 is one of the roots, meaning its factor is x plus 4. So we know that x plus 4 is a factor. And now we could, this now becomes negative 3x squared minus 17x minus 20. And we could factor out a negative 1, leaving us with 3x squared plus 17x plus 20. And we could try to factor this using product sum grouping if we wanted to. Okay? But instead of doing that, I'm going to go ahead and try another number. I'm going to continue with the negative 4. Remember, we've got to try the negative 4 again because we want to see if there's another negative 4 in there. And I'm trying negative 4 again. Look at that. We got another 0. Another factor. X plus 4 shows up again. And here's the cool thing. We're done. Because this is now negative 3x minus 5. So that's one of our factors, negative 3x minus 5. Now really, I don't like having a negative in my factor. So I'm going to factor out a negative 1 and make it 3x plus 5. Okay? So I've got a negative 1 up here, negative 1, and then a 3x plus 5. And now I can identify my roots and my factor multiplicity. I got to set each of my roots, or each of my factors, equal to 0. X minus 3 equals 0. X plus 4 equals 0. And I'm not going to write x plus 4 equals 0 twice. I only need it one time. Then 3x plus 5 equals 0. Okay? And so then I'm going to add 3 to both sides, and I get x equals 3. I get x equals negative 4. If I add 5, or excuse me, subtract 5. If I subtract 5 from both sides, I get 3x equals negative 5. Divide by 3, and I get x equals negative 5 over 3. So I've got 3 roots here. 3, 0. Negative 4, 0. And negative 5 over 3, 0. Those are my roots. Okay, those are my zeros, the places where the graph crosses over the x-axis. Last thing I'm going to do is identify the factor multiplicity. So I've got an x minus 3. How many of those are there? There's one x minus 3. So it has a multiplicity of 1. X plus 4. How many x plus 4s are there? There's 2 of them, right? Multiplicity of 2, right? So there's 2 x plus 4s. And then 3x plus 5. How many of those are there? There's 1. So that has a multiplicity of 1. And that's it. That's what you're doing for this. You're just identifying the qualities of a polynomial that are going to help us to graph the function. Okay? And then on Thursday, in the next set of videos, we're basically just going to take this information and we're going to graph the polynomial.